Hi, everybody, and welcome to today's webinar on taking 5G indoors with our special guest and industry influencer, Dean Bubley, as well as our very own Elias, product manager here at mmWave. We've got a really exciting webinar ahead for you, but just before we get started, I have a couple of housekeeping items to go through with you. The first thing is that we are going to be sending out a recording to everyone who registered or attended the webinar. You can expect that either later today or tomorrow. Secondly, we're going to take questions, so please use the GoToWebinar chat box as we go through the webinar, and then we've left some time at the end where we'll get to as many questions as we can. So with that out of the way, to get started, I'm just going to briefly introduce our guest today. We have Dean Bubley, who many of you probably already know, who's an industry influencer and founder of Disruptive Analysis. He's a well-respected speaker in all things wireless, especially the topic of 5G. And we have Elias, a technical product manager here at mmWave, who is currently working on the 5G capabilities for our mmWave design software. So with that out of the way, Dean, at this point, I'm going to hand it over to you to get started with the content.
That's great. Let me just quickly switch to my presentation. Thank you very much, Kelly. So my name is Dean Bubley. I'm an industry analyst and consultant, and I cover a whole range of different areas from wireless technology and telecoms industry strategy, in building, Wi-Fi, stuff around voice and video as well, and the sort of some of the cooler areas of technology such as sort of IoT. I'm also known by my social media alter ego of Disruptive Dean, partly because I tend to occasionally say controversial things or perhaps sometimes question the status quo. So I'm going to be talking today about the challenges and opportunities from extending 5G into an indoor environment. I'll be looking into indoor wireless generally, exactly what 5G can offer, and perhaps some reality checks on that, and also sort of referencing other technologies like Wi-Fi as we go through as well. One thing I'd like to start with is just saying that if I think back to my early days of covering in building, probably about sort of 13, 15 years ago, one of the things I remember was going to an event at around about 2006 when smartphones had just started coming out, mostly from Nokia, as you see here, and a few other companies like BlackBerry. And I remember having a conversation with people who were talking about what was going to be needed for indoor wireless in future. And I asked about data, mobile data, and the impact of smartphones, and also at the time, mobile broadband for PCs. And I remember hearing someone say, well, you know what? Data grows at about 6% a year. That's probably what we're going to expect in the future, and we'll use that as our planning assumptions. That was, of course, the year before the iPhone, and I suspect that those assumptions didn't hold true for very long. So what I've been trying to do here is look at what do we think is realistically going to happen, and also about some of the unknowns. What's the without descending into hype, what is the impact of some of the future 5G applications that we can realistically envisage? And I think on that, it's worth sort of revisiting what 5G is supposed to be about, and perhaps look at it through a different lens. Most people on the call will have seen this triangle of supposedly three main use cases for 5G: for mobile broadband, critical low latency IoT, and also the sort of more dispersed Internet of Things for sensors and the like, usually with a date of 2020 attached to them. First off, I would say ignore that chart. It was useful to begin with, but it's now sort of really only an element of the story. What we've seen over the last couple of years, and what we can expect over the next few years, first off, is to start with fixed access 5G, and that's already here in North America, in South Korea, and soon in the UK and Germany and other markets as well. And that wasn't even on the original list of use cases, really. That should probably expand. I don't buy into the view that it's going to displace cable or fiber connectivity en masse, but it's certainly an interesting and important addition to the landscape. For me, the big story is essentially taking what we have today and improving it. The last few weeks and months, we've seen various 5G smartphones launch, and a lot of operators over the course of the next 6 months will be lighting up 5G new radio in different spectrum bands, depending where you are in the world. But to be honest, it's mostly going to be more of the same, but faster and lower latency. And we can talk about the coverage later in this call. But yeah, unfortunately, for people who've been talking about more glamorous applications, at the moment, for now, it's just faster internet access on a phone, plus maybe your carrier has some specific content of their own as well. Where it starts to get more interesting is when the later phases of 5G start kicking in. Some early signs from next year, but really it's going to be sort of 2021, 2022, 2023 when all this really happens, depending on where you are in the world and how aggressive certain providers are. And I think this is where you'll start to see more interesting use cases around the low latency. You'll be talking about private networks or dedicated networks for vertical markets. Perhaps slices will come up in that discussion. We can debate whether some of the technologies that are being used for this massive IoT bubble are actually 4G technologies with a new badge on them, but there's certainly going to be more interest there as well. And the other side to this is what a term that you will increasingly see over the next few years, neutral host, which is where you have a wholesale network, perhaps with its own spectrum, a provider with its own spectrum, providing usually small cell based shared network capabilities for other carriers to either roam onto or get a wholesale component of, and that will be seen in building, but also for other use cases for neutral host in rural areas, and perhaps metro densification on the macro network, and also perhaps along road and rail. That's for a separate call, perhaps. And then, we've already had people start talking about 6G, and that's people are trying to avoid talking it up now to sort of saying, oh, 5G is the main deal for the next few years, and that's true. But certainly, if we think about long-term plans, this isn't the end of the line. What we'll see is a progression of going from today when 4G networks are dominant through to islands or patchy 5G, which will work in some places but not in others. And then we'll transition to a market where you have 5G as the primary use, and application developers and device developers can expect 5G most of the time, but we'll still need to engineer fallback options where it isn't, and that will vary again depending where you are, if you're in a big city, if you're in a rural area, and so on. One last thing is there's a lot of what I'll call fake 5G around as well, whereas some companies have realized that the easiest way to implement 5G is simply to change the logo on the screen rather than anything in the network, but I'll leave that one for now. So that being said about 5G, what are the use cases for indoor? And I think it's worth reiterating where we are today. And the majority of people on this call are probably interested in the top two use cases I'm going to have here. The first one is taking wide area mobile coverage indoors. Whether that's with DAS systems or increasingly small cells, perhaps Wi-Fi offload. But essentially it's taking your normal mobile service and making sure it works inside a building, whether that's a place of work or a multi-dwelling unit or anything else. The second major use case is what I'll call local IT and LAN and internet access. And this essentially is wireless computing, and particularly coming from PCs, tablets, maybe unified communications devices in the conference room. And today this mostly uses Wi-Fi, and it may be displaying stuff on screen. It would be printing things, going to servers inside the building or over the cloud. It may or may not use the public internet. It could be going to a private data center, but that's from a wireless point of view, Wi-Fi dominated. Then you have a couple of different categories of Internet of Things. The first one is basically static IoT, stuff which doesn't move around. It's lighting, heating and ventilation, air conditioning, maybe the video conferencing display. And this often will have a mix of Some of it's narrowband, some of it's broadband, but it doesn't need the mobility capabilities of cellular. And as a result, there's a whole variety of wireless technologies that get applied here, whether that's Wi-Fi, Bluetooth, outside-in coverage with LoRa and cellular NB-IoT, and that's going to grow hugely, but is slightly different to what we're covering here. The other interesting category which is emerging and increasingly important is what I call properly mobile IoT, things which move around. So I'm thinking robots, drones, maybe wearables on humans walking around a campus, and that's more likely to become cellular based rather than Wi-Fi, although Wi-Fi will still have an important role to play. There's another technology term that doesn't often get used in IT world, is this term OT, operational technology, which is essentially a term for the really demanding low latency critical systems. It could be industrial or medical environments, which have very, very tight availability requirements. Certainly in a factory, it could be millisecond or even microsecond latencies are important. Deterministic networking, and here there's an interesting debate as to how far 5G and 4G are going to go down that path. Wi-Fi is also aiming for that with Wi-Fi 6, but this is a really exciting area, and to be honest, we don't really know what's going to pan out. It also ties in with edge computing for the low latency. The last one which is relevant is local voice and things like two-way radio communications, where there is a big push in some industries to replace legacy systems with newer ones, particularly based on cellular technology. Some of these are local in building, like maybe a security guard, but some are wide area. And I think that we'll see a number of the service providers particularly look for indoor wireless coverage for cellular as a way of dealing with this. And this also sort of overlaps with public safety, which I haven't really included on this chart, but is also important. So if you look at what are the wireless networks that are used to deliver those use cases, today the main emphasis is public 4G and soon 5G for mobile network indoor coverage, using typically a DAS system, and then moving towards small cells in the future, and then Wi-Fi providing the internet and IT connectivity. And this will evolve both with the sort of private and neutral host cellular, new use cases for devices that are connected with perhaps cellular IoT. I'm not a believer in the idea that all our laptops are going to move from Wi-Fi to cellular. I think there's a lot of good reasons why that's not going to happen, except maybe in some very isolated examples. But also we need to bear in mind that there's various other wireless technologies around that are, as well as fiber for the internet connectivity and also industrial connectivity, that isn't going to go away. And I think it's this sort of concept of multiple networks and multiple use cases that drives some of the discussion around convergence. We will be needing fiber for a lot of this, both direct connection to some devices, but also as a way of enabling the small cell or future DAS capabilities for the cellular side, and also connecting the increasingly high capacity gigabit Wi-Fi as well. I mean, the way I would look at it is that the 5G era is changing things. And I use the word era here because this is not all going to be 5G, as I've said before. Some of it is going to be other technologies as well. But 5G, if you like, is it's almost like an emblem of the current period we're in and what's going to happen over the next few years. And that changes our perspective on what wireless in building is going to have to be in terms of the parts of the building we have to cover, the expectations of use cases, maybe peaks of demand, sudden growth, and also some of the level of importance where we start finding business critical and even safety and life critical systems depending on wireless. And so we have to start thinking about things like service areas. That's a picture of an elevator shaft there. You can imagine, and this is a little bit hypothetical, but imagine an elevator maintenance engineer with a augmented reality headset looking to fix a broken elevator. That is a not implausible scenario, but the wireless nature of that is quite tricky because obviously the elevator shaft is a long way from the outside of the building. It may not traditionally have been covered with all the wireless connectivity, and you don't know as the building owner whose network the headset is going to be using. It may well have an eSIM with a downloaded profile from an IoT specialist service provider, which is using who knows what network in theory. And so we have to start thinking through some of these end user application cases where the end user isn't necessarily just a person, but there may well be a device or an object or a robot as well. And also that means we have to start thinking about, voids, basements, stairwells, car parks, bits of the exterior building where we haven't really given much consideration in the past, but may well have IoT sensors in the future. And then especially in sectors like healthcare, there's clearly going to be a lot of other regulatory issues around safety and uptime and reliability. So this is a sort of an intersection here of three big trends: 4G going up to 5G with spectrum and radio technology changes. Small cells are going to become increasingly important for in-building, either for single operator coverage or increasingly multi-operator coverage. And there's going to be a somewhat of an overlap between small cells and cloud and virtualized RAN as well. I'm seeing virtualization both looking at for in-building, but also spanning the macro and in-building worlds, where you have disaggregation of baseband units and antennas. And I think that understanding how all that fits together between macro and indoor is going to be an interesting exercise for the next few years. And the last bubble I put on here is local spectrum models. And this is something that the US is probably leading the way in some respects with the CBRS band, which is a new shared spectrum band that's going to be made available on a county level for a variety of certain new classes of service provider. You might find the existing mobile carriers using it as extra spectrum. It's in the 3.5 gigahertz band, but you'll also have the cable MSOs, enterprises themselves, systems integrators, potentially industrial service providers, perhaps tower companies becoming more interested in the indoor environment, and a variety of other innovation use cases where building owners or campus owners can deploy their own networks in locally licensed spectrum. And there are similar things occurring, not quite the same, in most of Europe, in Japan, even in China. And some of that's going to be shared spectrum, some of it's going to be local licenses on geographic area, and some may be sliced up in different sort of subparts of a particular band and licensed on a temporary or dynamic basis. And I think all of this is going to lead to a whole host of new business models, but also challenges in terms of how this is managed, how the coverage works, how operationally the new owners deal with the tenants in that building who might be wanting to subscribe to them. And it's not just a radio problem, but also comes with complexities around core networks and SIMs and all the other parts of creating a mobile, essentially a micro mobile network. So I mentioned briefly spectrum there, CBRS, but that's only part of the story with 5G. And CBRS initially is going to be 4G and then evolving to 5G. But the broader story here around 5G is that there's a whole bunch of new bands. And while we're used to having many spectrum bands from LTE, that proliferates even further in the 5G era. And a lot of the focus goes on this sort of high and millimeter wave bands, particularly 24, 26, 28, sort of 37, 32, and a few other bands, and Wi-Fi running 60 gigahertz as well in some cases. And as I'll come on to in a minute, those have some significant propagation challenges, but they offer very, very high capacities indeed. And they're already seeing 28 being used in the US for the fixed wireless access. But once you start thinking about what this means for indoors, then it gets quite interesting. The other action I'm seeing is around mid-band, and certainly in most of the world outside the US for now, the key bands are 3.4 to 3.8 and 4.5 to 5. And certainly in Europe, it's mostly that 3.4 to 3.8 that I'm seeing here. And also we're seeing some of the existing 3G and 4G bands getting refarmed for 5G use, including some interesting approaches to sort of dynamic sharing between 4G and 5G on the same band by the same carrier. And there's a mix of FDD and TDD, which has additional challenges for implementing it in building. So the world is going to look quite complicated, especially when you also consider that at the same time we start talking about beamforming. MIMO stands for multiple in, multiple out. A lot of the carriers and the vendors are talking about network slicing, where you can essentially give virtualized networks with different characteristics on the same physical infrastructure. Edge computing often gets mentioned in the same context as well, where you have compute capabilities close to the edge of the network, either in the network or a localized data center from someone else. What's not clear to me is what complexities that brings for the venue owner or a third-party neutral host or building network operator. How is anyone going to be able to deliver end-to-end managed and perhaps premium priced quality of service when the in-building component is running on someone else's infrastructure? And it's not obvious to me how that's going to play out. And I think if we come back in a year or so's time, I think hopefully we'll have a little bit more color on that. I want to talk briefly about millimeter wave. Generally speaking, millimeter wave is great for line of sight over relatively short distances, but that doesn't necessarily mean that it's useless indoors, but at the same time, it will have interesting challenges and opportunities. The key thing is it won't necessarily be much use in locations like the hotel corridor, the photo on the left, because whilst you may get great coverage in the corridor, it's unlikely to permeate into the rooms through the walls and the doors. The other locations where maybe you've got a conference center or a larger passageway, you may well find that reflections mean that in an open plan space, millimeter wave actually performs reasonably, particularly even in an office environment where you've got chairs and desks and plants and who knows what. If you've got these multi-component antennas, it may work better, and some early tests have been quite positive. However, it's extremely early days. It's going to take a long time for people to really get their heads around deploying this, managing this, understanding the exceptions to the rule. And frankly, there's not really the skill sets out there today to do this at scale across all buildings. So I'm expecting millimeter wave indoors to be used sparingly and for certain applications and verticals. And speaking of verticals, it's worth saying that each industry and each subset of each industry will have a different profile of uses of 5G, whether that's for the broadband for guests and visitors, whether it's for low latency IoT, whether it's for sort of thousands and millions of sensors, and also in the likelihood of private networks or neutral host and service models being relevant. And this is a very non-granular slide. I could take any of these layers and boxes and break them up into many subcomponents. So for example, if you consider an airport, you've got the passenger areas in the terminal, you've got the baggage handling facilities, you've got the requirements outdoor on the apron for moving vehicles and so on, you've got maintenance areas, you've got offices, you've got retail. Each of those is going to have very different use case profiles and very different requirements for 5G, but also use of Wi-Fi and IoT technologies, and obviously different business models associated with the providers and owners of that infrastructure. Clearly, inside the terminal, the main focus is going to be on passengers, plus also the tenant airlines, check-in desks, and advertising boards and the information systems of the airport. But a hangar may only be owned by a single airline, not get many guests, and so perhaps they have a different attitude towards both network slicing, ownership of that infrastructure, and supported multi-carrier. So that's just to give one example. Each of these sectors will have many subsets and specific use cases. Wi-Fi quickly. My view, Wi-Fi is here to stay, but faces some challenges. There's a lot of people who sort of put out this erroneous concept of what 5G somehow damaging the prospects for Wi-Fi, and I completely dispute that. I think that for residential market, for carpeted offices, for PCs, for a lot of devices that are not smartphones, Wi-Fi is irreplaceable. As well as having a huge installed base and ongoing shipments, it has a lot of mileage that's coming through with Wi-Fi 6 technology and also potentially 6 gigahertz spectrum band coming soon. Also, some of the stuff that's being done with cloud-based Wi-Fi management points to some very clever abilities to optimize the network indoors for optimal performance. Where I see Wi-Fi perhaps facing challenges is in the public space, especially for those locations which have poor log-on experiences, and that's partly fixed with things like Passpoint, but I definitely think the sort of privacy invasive captive portal approach is likely to shift people over to cellular indoors. The other side is in the industrial space, where I think the 5G industry is doing a good job at least talking about some of this deterministic time-sensitive networking for production control systems. There's lots of different approaches to private and enterprise networks that are coming out. I've talked about some businesses building their own private networks, whether that's 4G and 5G, and we see that a limited amount today. So, yeah, I don't know, maybe mining in Australia, you'll find has a local network with its own spectrum on lease from a carrier, oil rigs, public safety agencies in some locations. But I'm expecting this market to explode over the next few years, partly because of the new availability of spectrum such as CBRS in the US and the industrial 3.7 gigahertz band proposed in Germany, but also there's this new concept of the neutral host, where you might find a hotel or an office development or a property company wants to become its own mobile network on a localized basis and allow third-party carriers to roam onto its infrastructure. Whilst that may sound like a lot of complexity, there's a quite rapidly maturing ecosystem of providers to assist with that, from offering cloud-based cores to the tool sets needed to deploy to managing the spectrum. So I think that's going to be interesting. And then, as you can see from the rest of that chart, there's other opportunities around network slicing, MVNO type models. This really is going to be quite dynamic over the next 3 years. At the moment, it's very, very hard to make predictions of exactly how that's going to shake out. And I strongly suspect it's going to vary a lot per industry, per country, and even down to the preferences of individual CIOs for enterprise. So to start summing up, there's a lot of knowns and there's a lot of unknowns around 5G and in building. And for me, this means that flexibility in deployment is going to be essential. Whatever infrastructure goes into the building has to take account of the fact we don't really know which bands are going to be used in future. We don't really know what devices and applications are going to be used, and we don't know what business models and who's going to be owning networks and operating them in the future either. What we do know is there's going to be more devices. Some of them will have very, very high throughput and latency requirements. We're still going to have a lot of other wireless technologies around alongside 5G. This multi-carrier requirement is likely to increase, especially with things like eSIM in devices and more devices which come out of the box with cellular provisioned. And there's more stakeholders involved, not just the carriers, but third parties, cloud providers, edge computing providers, new vendors. It's going to be quite dynamic, but again, means it's unpredictable. And the last one is individual vertical industries are going to have very, very specific tight requirements, whether it's for broadcast, or ports and airports, or health and safety from an oil and gas or chemical plant. What the regulatory requirements are on privacy and all sorts of other issues for smart buildings and so on. What we don't know, first off, millimeter wave realities. It's looking like millimeter wave is going to be good for some things in building, but not everything. There are certainly going to be upsides and downsides we don't anticipate, and so I think that's something to keep an eye on and look for real world deployments as well as the simulations. I mentioned before about the quality of service issue. How exactly carriers or other companies are going to provide end-to-end quality of service across someone else's in-building infrastructure? And I think that's a real outstanding question. And when you hear people talk about network slicing, I'd always ask them, how does a slice translate indoors? There's the extent of private, well, 5G and also 4G deployment. There's a lot of enthusiasm at the moment, but that needs to translate into reality. And whilst there's a lot going on, which is a positive sign, and there certainly seems to be appetite from enterprises to run their own networks, there's still some economic hurdles, skills hurdles, and others. Cloud RAN and related technologies like the O-RAN architecture, again, is one of those things that we can see coming, but exactly the extent of it, what happens with existing legacy buildings, with existing in-building wiring is unclear, but again, that's going to likely to be patchy, but we want to keep an eye on. Spectrum licensing and sharing, whether that's in North America or elsewhere around the world, is in a huge state of flux at the moment. So we know about CBRS, but even there, we haven't got the auction dates for some of the dedicated license bands within CBRS, probably next year. And then we have the other potential around 6 gigahertz and C-band, which again is going to work its way through the FCC over time. We also have this desire to converge between mobile access points or small cells, Wi-Fi access points, having Ethernet and optical connections for fixed computing devices, which are not going to go away, as well as enabling the mobile aspects of this as well. And we may well find interesting hybrid devices both on the infrastructure and devices which can use multiple networks and aggregate them or steer traffic. One of the things I'm expecting to see is essentially the wireless equivalent of SD-WAN, where software determines which of several network connection mechanisms are optimal for a given device or application at a particular time. Edge computing, I haven't really got into it. It's a topic for a whole other discussion. We may find that some parts of buildings end up looking like server rooms, or you might find there's a shipping container with computers, server racks out in the car park somewhere. I'm not sure yet, but there's lots of different arguments around the architecture of edge compute, whether it's going to be integral to the carrier network, whether it's going to be mini data centers or something else. And the last one is what is the future of wholesale, and in some markets, what is the future of government-sponsored networks or networks in government buildings? One thing I will say that we can be fairly confident of, though, is that deeper fiber is going to be needed everywhere, within buildings, but also across the macro network and along streets and so on for small cells. I think that's an inevitability, and that presents some interesting challenges for the parts of the buildings which haven't historically had connectivity in them, and also it's something I think that property developers need to really give consideration to in advance of constructing new locations. So I'll leave you with this slide. And I've gone through pretty much this whole presentation without talking about autonomous cars and self-driving vehicles generally. I'm a big believer that autonomous vehicles need to be autonomous, and they're not going to necessarily be always connected. They will rely on their onboard compute and their cameras and LiDAR. And then I started thinking about underground car parks. Imagine in 10 years' time, you get out of a car and then you tell it to go and park itself while you go into the building. And it goes and parks itself in the car park underground within the building. How does it let you know where it parked? And how does it then, when you want to get picked up and you hit the button on the app in your phone to say, meet me at the front door, how does it know? You'll still need coverage in that car park, irrespective of whether the car can steer itself or not. And I think this is one of the lessons here is we have to think about the unpredictable future and think about the user journey for 10 or 100 different applications and use cases. And in this case, the user may not be a human or in a normal part of the building. It may well be it may be a robot. And I think that's the sort of today's equivalent challenge of the 2006 smartphone. And on that, thank you. That's the end of my presentation. Zach, I'm going to pass this across to you.
Thank you very much. Thanks a lot, Dean. That was really great.
Great. Zach, have you got that?
All right. Yes, I'm there. So thanks a lot. I appreciate that. Actually, it's a pretty good lead into what I'm going to talk about. So I'm Zach Elias, and I'm the technical product manager at mmWave, but I won't get too deep into the actual product. Instead, I want to take a look at quickly this picture. And this is the universe that people currently live in when they talk about 5G. It's how do I get 5G to an entire city? And so the use cases for that are coverage and making sure that I'm covering all the issues that I want around certain buildings or in a park and so on. But what happens when you want to get indoors? And when you want to go indoors with 5G, you start having to think about what you currently have and what you actually want to get to later. So let's take a quick look inside. So inside this particular floor of this building, it's a typical office, and this office happens to have 4 pre-existing cells, and those small cells are emitting at 700 megahertz for an LTE, and guess what? When you look at that, plus the Wi-Fi that they currently provide and the coverage that you get in that building, you get a picture that is typically something like this. So deep purple means excellent coverage and the highest possible speed that you can get at LTE. And that's great. So you might think to yourself, okay, so if I want to move to 5G and I wanted to get to a 28 gigahertz space for that, because millimeter waves are going to offer me even a faster speed and so on, I could, do that switch and it should be pretty easy. Maybe I have to swap out a couple of cables to provide a fiber backbone to these cells. But I'm looking at this current office that I currently have, and as a building owner, I might say that should be what could be done. Why? Why would people even want 5G inside of a building? And it's the same overall experience that you would expect for clients outside of the building. And it's not just people, it can also be things like drones and other things that happen to require a certain connectivity, a certain latency, a certain data rate, so that my video conference call doesn't degrade as soon as I enter the building, because people want what they expect outside to come with them on the indoors as well. And 5G currently promises faster data. It promises a really low latency, and it really also promises the fact that you can get a higher density of connected devices. And that's, as we've seen in our own lives when it comes to a smart home and so on, we're injecting more and more connectivity pieces into our lives, into our wearables. And this is translating into an office space as well, with whole smart building initiatives that require things like Wi-Fi and Zigbee and all the other technologies. But there are things, as we heard earlier from Dean, where there are mobile use cases like augmented reality glasses and so on that will require this kind of connectivity in order to move forward in the future. So yes, people who want faster data access are asking questions like, why do I need to wait before my video is uploaded before I can share it? Why do I have to deal with pixelated calls? And why do I have to deal with LAN to actually do this webinar? Wouldn't it be great if I could just use the 5G that I've been promised will offer me low latency and stable connectivity with all the devices in the area? I mean, I would want that. And I could say, looking at my floor plan, where previously I covered everything, I might be on the safe side. And I'll say to myself that I would like to cover at least these areas here that are highlighted with decent 5G coverage. I've got a whole set of cubicles on the far right and some main offices, and I want those to have high-speed access. Great. Next. Maybe I'm one of these people that runs or plans to run some kind of remote surgery. I know it's very cliched, but it could be an automated workforce of drones. It could be that it's a smart car. It could be that I have a bunch of devices that need to connect to each other really quickly. There are cases that you've seen in advertisements of people playing augmented reality games. And in those cases, you need an extremely low latency to survive. So in that area, I might say to myself that in this floor plan, this particular area here is something that I need to ensure that has this low latency aspect to it. So I might want 5G connectivity there as well. And of course, more things. So as I said, people walking in with wearables and augmented reality glasses. And although things here are listed quite mundanely with light switches and coffee, when you think about what's happening in an Amazon warehouse, they might be actually pushing that drones are all automated so that when a human walks through the area, that it's not going to be interfering with people and with themselves. And for that, you need connectivity, you need the low latency, you need data, you need all of these items. And in this sample office space, maybe I'll designate this one room here as something where I'm going to have a high density of connected components. Right. So if you take a look at that same office space, there are 4 small cells as I listed. And the question is it an easy swap? Let's say I wanted to do mmWave deployment. If I were to just swap them over, turn them on at the exact same power, I end up with a picture like this. The picture is not going to be a surprise to anyone who's thinking about millimeter waves. In its existing state, if you look at the far right where I have low-lying cubicles, where essentially there's line of sight, I'm getting that entire space covered. It's not covered as hotly as it was with LTE, but it's adequate for people to do work. And even in this space, they'll probably be getting a very high data rate, maybe even 400 or 500 megabits per second. But if you look out in the halls to the left side, you'll notice that I'm just covering whatever space is available when those rays are actually hitting drywall or doors or any other material. And the reason is what you would expect. I mean, higher frequencies tend to attenuate more when they pass through certain materials. And so this doesn't actually work. When I wanted my whole space that I'd marked off, you'll notice that the top right and the far left are just dark. And dark means there's going to be virtually no connectivity. So in a millimeter wave situation, you can tell right away that there's an issue, and that means that there needs to be a kind of evolution that starts to need to be planned. How do I take my current office space and how do I move it in a direction where I get the coverage that I want? And then it becomes very much an exercise of understanding what your use cases are and where you want to send this connectivity to get those benefits that people have been promising: more data, more connectivity, less latency. When it comes to millimeter waves, at least, you need to be very, very aware of what your use cases are. And those use cases are exactly what Dean described before. And they're going to be evolving as technology and as people start to create new things and decide that some other service is the new hot one and we need it and it requires this low latency aspect. If this was a sub 6 gigahertz or mid-band frequency, you'd probably end up with a lot more coverage, right? You would expect that to happen with a much lower frequency. You're going to get a lower data rate, but it's still going to be a 5G data rate with approximately 10 to 15% increase on those mid bands, but you'll get a lot higher coverage, and that depends really on what's available in your region and so on. So as you'd expect, as I said, in millimeter waves, the obstructions really matter. The walls matter, the doors matter, the type of window, the chairs, the desks, every small thing now makes a very big difference. And if you'll notice that on this page, I went from 4 small cells to 8, which doubles or perhaps even much more so increases the cost. I have to maintain and upgrade the actual infrastructure, which means I have to include more fiber. Maybe I have to disrupt work. That density now starts to increase dramatically, and that changes the overall flow of what's going on in your actual workday. And even with that, I've doubled the number of cells, and I've covered areas that I want, and I've increased the coverage on the right side with the actual cubicle space, and that could be sufficient for me. But again, it's indicative that when it comes to design of an indoor building, you must be aware of, again, what those use cases are so you can really start to target and plan how those upgrades will evolve over time. And of course, that does raise the question is, what do you do when you're a building owner and you need to establish 5G? A lot of that backbone will be fiber. So some of the future proofing will be that you start to install fiber in a lot more locations in your building. So let's take a quick step back and you look at your entire building and you need to ask yourself those questions. What do I do with my infrastructure? What kind of network do I need to build? What are my use cases? So when it comes to things like your existing infrastructure, you really need to understand what it means to have either a millimeter wave or sub-6 gigahertz network. If you're doing things in sub-6, you can reuse some of your hardware. Maybe you can reuse the same sites. Maybe you can even swap out some of the passive antennas. But if you were to do that, you'd end up losing a lot of the technology that's built into these new systems. 5G is, as stated before, it's a lot more than just setting things out faster. It's things like network slicing, and there's a lot more happening at the edge, at the cell, at the actual emission of the signal. Things need to be accounted for like beamforming, massive MIMO. Those require an intelligence that if you were to just swap out your existing DAS system and try to go into a sub-6 gigahertz 5G system, it would probably work in some cases, but you wouldn't be getting all the benefits that you need. And if you were going to go about a millimeter wave network, then at that point, it really becomes imperative to understand and do this preemptive designing, this before and after scenarios, so that you can understand from the beginning all the way to the end of the actual construction, where does that fiber need to go? Does it need to go to these particular rooms? How much work is that going to take? What is the cost? Am I disrupting people's workflow during the day? And of course, overall, that really means 5G in its current state is very much a question in understanding your capacity needed, the cost, and the overall need. So in this floor plan, I had marked off two different areas that needed specific 5G features. So in that case, it was low latency and IoT. I also need to be thinking about, what do I want to do about beamforming? How much data access do I need? What is that user flow that I expect when I'm a person coming into this office? I don't want to be a person who's going into a hospital struggling to find a place that doesn't have a dead zone so I can make a phone call. I don't want to be that person who comes into the office with work ongoing and getting interrupted or slowed down in that process. These are things that you need to think about into actual use cases and user scenarios that are important in developing what 5G means. So when it comes to things like an airport, you might target 5G at places where there's a high density of users that are currently waiting and have, an opportunity to look at their phones. It could be baggage claim. It could be that they want to send a video at an actual gate. And then you could decide that elsewhere in the transit, in the actual walk between one gate and another, that a 4G network is sufficient. In conference rooms, in actual conferences, of course, that's an important place that you might decide that is necessary to have 5G. A boardroom, any high traffic area that you designate as needing this technology is something that you need to think about and plan. And yes, you could say to yourself that I do want to have full coverage at the end, but it's important to understand how to get from your current state in a 4G network all the way to the end goal, which could be full coverage. And finally, this concept of 5G compute. As I said before, a lot of 5G is about edge computing. Sitting at a small cell, they're much smarter than they used to be. They have to be in order to understand capacity and traffic and to understand where to direct beams dynamically. There's a lot happening there, including network slicing, which is still a big unknown. And all of these things need increased computational power, and that could happen either at a building RAN, it could be in a cloud, it could be somewhere centralized in a campus. But all of those designations as well require you to understand what the impacts will be on that latency. I mean, if you have a distant cloud RAN that's a good 100 kilometers away, well, you're going to impact your latency, even if marginally. And if that's important to you, you need to understand what that means. And maybe you want to have something on-site versus off-site. So from point A to point B, when you're talking about going from your current situation all the way to the end goal. We're talking about convergence. We're talking about how to move your system, your building, from what its current state is to the end. And maybe that means understanding how to hook up fiber to that apartment building, to your office building, to your home or your office, because it's going to be necessary for 5G. It'll be understanding where you want that coverage. Where are those use cases important to you to set up 5G connectivity, 5G strong signal to allow work to continue? And then it's also going to be a question of how do you get Wi-Fi 6 to be able to get in there, to be able to compensate in locations where you just can't supply this kind of coverage. Because you don't want to have a situation where, exactly like Dean said, you've parked your car and at the end, the car has absolutely no way to tell you where it is. And you have no way of telling it to go and retrieve itself and wait for you outside. You need to be able to be aware of what those use cases are so you can design your networks to accommodate whatever's happening in the future when it comes to 5G, because it's going to hit us whether or not we like it. And at this point, I can open it up to questions, because that's the overall end of designing indoors.
Thanks, Zachary, and thanks, Dean. We've got a good list of questions here. We will get to the ones that we can cover in the next 10 minutes. So I'll just start going through the list here. So will we be using 4G and 5G in unison, voice and data over 4G, video and high bandwidth content over 5G? Thoughts?
I'd say, yeah, as Dean, it's probably not going to be separated out by application quite that way. What you may find is in the early stages that you might get 5G downlink and 4G uplink, and then it just depends on the device you have. Yeah, I really don't think it makes sense to steer applications to 4G versus 5G in that fashion, particularly because 5G, if you have it, is more efficient spectrally. So I think if it's a 5G device, the inclination will be to use it on 5G. But where it might vary is which spectrum band and which slice that gets applied to particular applications or devices.
Okay, thank you. Do you see 5G deployments in data centers? And if so, in regard to mmWave, do you expect interference will be a concern?
In a data center environment, chances are you already have a fiber hookup, and that's going to be much, much more reliable. It definitely, if you talk about mmWaves, when you talk about very tall racks of metal, it will have a huge impact. I would have a hard time seeing any of that be operated wirelessly, unless there's some kind of automation bot walking around, roaming and doing something. I can't picture it happening that way.
I would say data centers, and I've been to quite a few data center events recently and spoken to people in that sector. And I think inside the data centers, you certainly have Wi-Fi because there's people who are going to be using phones and tablets to do operational tasks. But it's a fairly very well defined physical space. And so, I think that you'll find that there is some use of different sorts of wireless technology, but I would imagine that it's likely to be Wi-Fi predominantly, perhaps not for connecting servers, but more ancillary equipment and IoT devices. I've seen people using things like AR headsets to work out which wire cable and plug goes into which socket and things like that. 5G, I'm sure we'll see some demos, but I don't think it's a key market in the near term.
Okay, Zach, these two are for you. Does mmWave support 28 gigahertz for 5G? And when will mmWave release mmWave version?
The answer is yes. It will be released at the end of this month, and we will support 5GNR on all the available 3GPP bands. So FR1 and FR2, they will all be available.
Okay, great. Will operators reconsider direct indoor investment with 5G or continue with the current 4G approach of less and less investment? Thoughts?
I think that's going to be very dependent on the venue and on the national market. I think some carriers who are aggressively promoting 5G will want to see their customers, especially if they're paying more, see their 5G logo on their phone in more locations. And I think there's going to be some incentive to encourage buildings to upgrade, but probably only the largest and most important ones, maybe an airport or a big shopping mall or something like that. And the other thing that I expect carriers are going to do is bend the rules a bit on when your phone can display a 5G icon. That's something which is by far the cheapest way of doing things. I think that you will see new classes of service provider, whether you want to call them carriers or not, is open for debate. And I think that whether those are the neutral host providers and the tower companies, or a variety of niche players, is going to be very interesting over the next few years. One of the things that people talk about is that 5G is going to transform industries. I think what they don't realize is the first industry that gets transformed is the telecoms industry itself. And I think that all of these issues are going to start to drive emergence of new forms of service provider, of new business models, and blur the lines between carrier and enterprise a lot.
Okay. This question is millimeter wave better than sub 6 gigahertz because of higher frequency equals higher speed? There's a lot more available bandwidth at those frequencies, or both.
Yeah, so that question really is a use case question. Or if you're looking for multi-gigabit per second wireless speeds, millimeter wave is your choice. But it has the drawbacks that I specified. Are you targeting a particular room? Are you targeting a particular use case that you want lots of people to connect and upload a lot of video? It could be in a stadium where you're expecting a lot of people to upload videos of a game or their own reactions and so on. In those cases, millimeter wave makes a lot of sense. And it can make sense indoors. But you have to decide whether or not what's important to you. Millimeter wave will definitely offer you higher bandwidth. Was that higher bandwidth worth the reduced coverage? That's the question needs to be asked.
Yeah. If you think about where people send Instagram videos or live broadcasts from, I don't expect every sort of bathroom and interior room in every building to have a small cell in. So that's going to have to be using sub-6, whether that's in a residential space or an enterprise. On the other hand, if I've got a conference room and everyone's on their phone, I want the maximum capacity density, and I also have lots of things to reflect MIMO beams off of as well. So that's perhaps more of an appealing environment.
Okay. Zachary, this one's for you. When beamforming simulations will be available in mmWave?
So beamforming on its own will be available at the end of this year. Betas will come out much earlier as usual, but it is something that is planned for the end of 2019.
Thank you. Let's see. How is 5G affected by existing broadband devices in buildings, for example, Wi-Fi and Bluetooth?
Well, I mean, unless you're deploying in an adjacent band, there shouldn't be interference. But I think that the effects come in terms of whether you can co-locate the access points and radio heads, and that depends a bit again on the frequencies chosen, and also on again the use cases of which technologies can be used for what use case. And I expect Wi-Fi to still continue to be needed everywhere within a lot of offices, residential buildings, and sort of public spaces where people may well have non-cellular devices. Bluetooth is likely to be used for the sort of static IoT use cases controlled locally via a gateway. So I think that those are interesting, but I don't think it's going to sort of interfere or detract from the 5G deployment and uses.
Okay, great. So with that, we have hit our timeline. I know we didn't get to all the questions, so apologize to those who asked and we weren't able to get to them. I'd like to extend a big thank you to Dean for joining us today and to Zach Thank you both for a great presentation, lots of thank yous, and well done on the webinar comments. And thank you to everyone who joined us for today's webinar. We will be sending out a recording by tomorrow. Thank you.
Fantastic. Thank you.
Thanks.